and welcome back to the AI in Action video series. Today we're really lucky to be here with Professor Kolter, who is the head of machine learning here at Carnegie Mellon. His research spans several topics, including AI and ML, where he works on like AI safety, robustness, and LLM security, as well as much more, which I'm sure we will hear about. In addition to that, he also serves on the board of OpenAI as a chief expert for Bosch and the chief technical advisor to Grace Swan. I'd also kind of love to hear more about the current research you're working on and your focus.
Of course, I have a number of projects that are focused on what I would broadly call AI safety. And this ranges really from technical kind of robustness of machine learning models to benchmarks to sort of more general ways of looking at how these systems interact with humans and users and this kind of thing. But I also have a number of other projects too. So even though I would argue that algorithmic work hasn't been quite as relevant in the past few years in AI, we do have plenty of algorithmic approaches, right? So I constantly am thinking about new architectural designs, new ways of leveraging more information inside of models. And so we have a number of those projects. I don't think I'll ever be able to stop working on some elements of sort of algorithmic AI. And then I also would say the field of AI has undergone such change in the past few years. And one of these big changes is that there's been more of an emphasis on what I'll kind of call the empirics of AI. It's sort of this notion that a lot of the large AI models, you really can't analyze them sort of from mathematical first principles anymore. Those models don't really make sense in that context. Instead, you really want to think of them kind of almost like biological systems, just like systems that exist out in the world. Yes, we've created them, but it's almost beside the point. And we do a lot of work in, what I'll broadly call kind of the empirics of understanding these systems as the emergent phenomena of these systems kind of as just existent complex systems that exist in the world.
Do you have any kind of idea for a forecast of where you think AI is going in the near future, I guess?
5 years is a long time. And I think within 5 years, there's a very good chance we see systems that are exceptionally capable in a way that gives us all a lot of pause when we sort of think about the nature of intelligence, think about the nature of sort of our own relationship with intelligence. I have a very wide uncertainty about when I think machines will reach true kind of general purpose intelligence, but it could happen. At least in 5 years, we could make substantial progress along these lines to the point where we have these sort of modular intelligence units that are out in the world that can do things for us, that can kind of take long temporal extended actions on our behalf. And I think there's a good chance we get there in 5 years. Massive uncertainty, to be clear, about exactly when this will happen. And I'm constantly kind of trying to both be skeptical of the impressions I'm getting, but also open to new ideas. I think academics on the whole are far too skeptical about these things. And so I think that there really is a lot. 5 years, man, a lot's going to happen.
What advice would you give, I guess, like current undergrad students who want to get into AI or ML research?
If you want to be doing research in AI, I think it's still, for the time being, who knows how long this will last, but for the time being, it's actually not that different. You need to probably learn how to program, but that's going to change entirely in the next few years, how we program. It might be you need to learn how to instruct language models to write the programs that you want to learn, but that's still a skill that you have to develop. You need to learn math, but the way we learn math, I think, will change dramatically as we start to leverage AI systems more. And you have to, you probably have to develop some skill in evaluation and sort of understanding of the kinds of problems that can and can't be solved by current systems. Beyond that, though, I would just sort of say that, look, there's a number, and I would say a growing number of ways in which you can be an AI researcher. I think that for a long time, we sort of focused only on the technical kind of side of developing new algorithms, but there really is a wide expanse of understanding, just the behavior of AI systems. Like I was talking about before, the biological kind of analysis of AI models, right? these changes open up really new possibilities for how you think about being an AI researcher. And so, if anything, the door is much more open in terms of what qualifies as AI research, and you can approach the field in a lot of different ways. The one kind of unifying recommendation I would make, which I think probably new undergrads have no problem with this, is actually the older students and certainly the faculty that need to be told this, is you really need to use AI a whole lot, because if you don't use these systems, you're not going to have a very good sense of what is the real problems with them, what are the current gaps, what are the current ways in which they either can be manipulated or can make kind of can raise safety concerns. um, and so you have to also, just from a fundamental standpoint, be familiar with the operation of AI models. And there's no substitute for just practice and getting used to interacting frequently with AI tools. In your own personal sort of development of code and stuff, use AI tools broadly. Um, Start reading papers and use these models as ways of summarizing papers and things like this, and explaining papers in a way that makes sense to you and stuff like that. They're very good at these things, and so I think being kind of in some sense a native of AI models is also a very important prerequisite these days for working with AI systems.
I'd love to hear about something unexpected that happened in your career that you're really glad happened.
I would say that most of my career is, as I mentioned, at the beginning here, getting into the field due to a stroke of luck of being late to start my undergraduate program in CS. I would say that most of the big events in my career have been kind of happenstance efforts. Um, I think that there have been certain, I mean, all research projects, even the ones that I am now very focused on, that I spend a lot of time on, they come either on my own sake, or more and more often, honestly, from the sake of from the inspiration of students. They come often from sort of very small little moments, and I actually remember a lot of these moments of sort of, I remember some of our first work we were doing on analyzing robustness of deep networks, and we were thinking about certain formulations of this and how we formulate it. And at one point, I remember I was I was at the car shop waiting for my car to be repaired, and I was writing down some equations or something like this, working through this math, and going back and forth with a student, we realized that you could actually optimize this particular problem really efficiently by solving a different neural network. And it was sort of this epiphany that's, oh my goodness, this actually could be more practical. It ended up being, in the big term, I would say, wildly impractical, but I still, a lot of my career was based upon those sorts of things. A similar thing I think happened recently with our work on jailbreaking models using automated optimization. It was sort of, we were playing around with models. I remember at one point I was trying to get a model to give a rest. We're trying to jailbreak models, right? So a common thing you ask a model to do is produce a way to make a bomb. And we were dealing with really bad models. This was, Llama 1 style models, and I thought it was so hilarious because we had ingredients for a bomb, and the first ingredient was something like 1 unit of explosive, or C4. That already is a bomb, right? So it's not very good. But then I kept giving other ingredients, and eventually it became ingredients of pumpkin pie. And I thought that was hilarious because it was like this pumpkin pie bomb. So there are little moments in sort of research, but at the same time, that was the first insights we had on sort of getting models to generate specific outputs that we were trying to manipulate them into. And so there are all these little sort of moments that have come up that I remember, these little kind of technical breakthroughs where we said, oh, that's kind of interesting. And then in hindsight, they led to these massive research agendas. And so I would say that for the most part, the thing that I have found most surprising kind of globally as a meta comment is that very often in research, at least previously, we'll see if this continues, by the way. I mean, one of my fears is that AI research, if it moves too far away from sort of core kind of exploration, I worry it's going to lose this kind of spark. But let's assume that doesn't happen. I think that a lot of unexpected things in research, or a lot of sort of research agendas, happen from some little spark where you're implementing something and you see something a little unexpected, or you're writing out some math, or you're just sort of ideating for a while, and you have an idea, And it doesn't seem that, often at the time it doesn't seem any different from any other idea you've had. I've had a lot of ideas that don't pan out at all. But looking back, I very distinctly remember a lot of these sort of sparks of new research agendas that kind of come, and the pumpkin pie bomb was one of these. The writing out the dual of a linear program that assessed robustness of machine learning is another one. Um, Writing out this, I remember another time I had lost my voice, and so I was trying to have meetings with students when I would just write things down. I was writing down some architecture that we were sort of doing, and it sort of find a combination between an RNN and a CNN, sort of thing, this recurrent neural network and a convolutional network. And again, all these things in hindsight are, they were just little moments, but I remember them, for me at least, as sort of these sparks of new entire agendas of research. And I find those moments just infinitely satisfying and valuable. And I hope to never sort of lose those to a certain extent, right? I mean, I do less research myself these days. It's just the nature of becoming a faculty member. You outsource your research to students. Students are the ones doing the work for the most part.
Like, is there one kind of common misconception about AI that like you wish that you could dispel?
Man, there's so many misconceptions about AI. I'm going to give the answer here that I think is very different from most faculty. I think most faculty, when they're asked this question, they talk about the overhyped nature of AI as it currently exists in the world. That, the misconception is that LLMs are really intelligent when they're just these autoregressive machines. And I could not disagree with that statement more. I think actually this misconception comes from senior academics in the field. And the misconception is that because you've worked with these models and because you understand the functional sort of nature of how these models work, there's a notion that you therefore understand the limits of what AI systems based upon these models can do. So yeah, you understand what a transformer is, you know what a basic neural network is, and therefore there is, I believe, the fundamental misconception that you somehow understand the emergent nature of intelligent systems that come about when you apply those things on massive amounts of data. There's this there really is this understanding, I would say, in a lot of, not the younger people, to be clear, in the field. I think in general, I think sort of the new generation just accepts on face value that these systems are intelligent. Yeah, we're going to get to generally intelligent systems in a few years. Of course we are, obviously. But the senior academics definitely don't feel this way, for the most part. Not uniformly, but the vast majority don't feel this way. And that's actually a misconception that I'd want to sort of fixate on to a degree. I think there is a misconception that because you understand and have worked with the mechanics of machine learning models, that this means you understand the nature of the resulting systems that come out from these things. I would actually argue the opposite is often true. Often our limited understanding, I think, of our deep understanding of the mechanism behind these systems actually leads us to be overly confident in what the resulting systems can and can't do. It is a really dangerous thing to predict that AI cannot do anything. And you can take any benchmark that exists out there right now, and I would take a bet with almost anyone that within 2 years will be able to pass it, maybe within a year. So I know there was just this frontier math benchmark that came out. All models get less than 2% on it. Does anyone want to make a bet about how long that will last? I mean, it's not going to last, right? Like, we all know this. They'll pass it like everything else. And you could argue that those benchmarks aren't really good measures of intelligence, things like this, but there's no end of people saying that because current systems operate in a certain way, therefore these things can't do X generally. And I just disagree with this. I think that we overgeneralize the current limitations of models, our current experience with models, and our understanding of how current models operate to make inferences that are just not justified. And so maybe the misconception fundamentally is that AI experts know what they're talking about. I think when it comes to predictions of how AI will evolve, I don't think experts know what they're talking about. That probably goes for people that are making very optimistic predictions as well. No one really knows. And we all have our guesses, we all have our assumptions, but I think everyone should be a bit more humble and just willing to accept the fact that something amazing is happening. Maybe it will slow down, maybe it will stop, maybe we will create truly what no one can deny are truly generally intelligent systems. I think probably somewhere in the middle is where we'll land. But I think that there's this is how I would sort of phrase things, that, you know, we are at this precipice of amazing performance. And I think no one really knows how it will go, including very much the experts in AI.
Yeah, definitely. Well, thank you so much for all of your insights. We've really, really enjoyed learning from you.
Thank you so much.